dear students, welcome to our YouTube channel Diksha Karnataka. So now your midterms exam are approaching and many of you have put requests for having revision or give some important questions. So here I am today with the midterm revision video for two important chapters, that is Solutions and Electrochemistry. Okay, so we'll be discussing like we have analyzed last 15 years questions paper which were asked in the board examination, supplementary examinations, and then we have selected very important repeated questions. So these type of questions or similar questions you can easily expect in your midterm examination, right? Many of you are not taking your midterm exam seriously. I know the marks will not be included, but yes, this if you are prepared now, you will get enough time, you will be more confident for your board examinations. So please take your midterm examinations also seriously and prepare properly for this exam. So to help you with this, I have come up today. We'll be discussing these two chapters of physical chemistry, and in the next two videos we'll be covering organic and inorganic chemistry also. Okay, so now I'll be giving you some most important questions. I'll be telling you how to solve it. You need to practice similar questions, and these questions and whatever theory questions I'll be discussing, you need to learn their answers also. Okay, so without any further delay, let's get started towards our midterm preparation. Okay, so first of all, coming to physical chemistry, in your midterm syllabus you have two of these chapters, right? Solutions and electrochemistry. And then if you see solutions chapter weightage, okay, so total weightage of solutions chapter is 12 marks, right? You will get total 12 marks according to the blueprint released by the PUC board, right? 12 marks from this chapter. Now if you know your questions are of four types, right? The questions are of your like remember based, where then you have understanding based questions, then you have application based questions, and then you have HOTS question, right? High order thinking skills. Now if you see here, in case of solutions, you have, and what are your question pattern? You have 1 mark, 2 mark, 3 mark and 5 marks, right? So if you see for solutions chapter, you will be getting 3 MCQs or like 3 1-marker question. It can be fill in the blanks or MCQs, but you will get 3 1-marker questions. So it can be either MCQ or fill in the blanks. Now these 3 questions are coming under these 3 categories, that is remembering, application and HOTS. Okay, so R stands for remember, A stands for application, H stands for HOTS here. So these 3 MCQs are of these 3 types. So you got 3 marks here, so total is 12. Next you have short answer questions of 3 marks, and this also you will get 3 questions. So 3 into 3, so total 9 marks, and here 3 marks, 10, 11, 12 marks, right? And these 3 questions are again of your remembering type, understanding type and HOTS question, right? And this understanding is a numerical problem question, HOTS is also numerical problem, and this can be a theoretical question. I hope the pattern is very clear. You will get 3 MCQs, okay, and you will get 3 3-marker question. Out of that, 1 will be theoretical and 2 will be numerical problems. So if we master the numerical problems of this chapter, then easily we can get 6 marks. And theory, there are very few questions which can be asked, which like very few and known questions which can be asked in the theoretical question. So it is very easily you can get this 9 marks, okay, and we'll be also practicing certain MCQs so that you can get confident on that also, okay. So now let us go to the first one. We'll be doing with very short answer, that is 1-marker question. So I have taken around 10 to 15 MCQs for your practice, okay. So now let us see, which of the following units is useful in relating the concentration of solution with its vapor pressure. So if you have remember, vapor pressure, partial pressure is equal to P naught into mole fraction, right? So mole fraction is the one which relates with the vapor pressure. So correct answer is option number A, okay. Now let us see the next question. On dissolving sugar in water at room temperature, solution feels cool to touch. Means what? You have taken a solution and you have dissolved some, you have added some sugar and you added some water, right? And after some time you feel that the solution or the container has become cold. So that indicates that this sugar particle have absorbed the water from the heat to get dissolved, right? It has taken inside the heat. That means the process is what? Endothermic, right? So dissolution can be both endothermic and exothermic. So this statement indicates that dissolution of sugar is an endothermic process, and endothermic process increases if you increase the temperature, right? So that is why we can eliminate the cold water options. Hot water, hot water. Now sugar crystals, powdered sugar. So definitely sugar crystals will take more time to get dissolved as compared to the powdered sugar. So correct answer will be option number D here. Okay, why? Because the surface area of the powdered sugar will be more. Okay, next, at equilibrium the rate of dissolution of a solid solute in a volatile liquid solvent is less than, greater than, equal to the rate of crystallization. At equilibrium the rates are always equal, so correct answer is option number C. Next, a beaker contains a solution of substance A. Precipitation of substance A takes place when small amount of A is added to the solution. The solution is saturated, right? Once it is already saturated, if you add one more compound, right, one more particle, the particle which is already dissolved. See, suppose here 5 particles are, or let me take 9 particles was the maximum capacity, and 9 particles you have already dissolved. Now this is a situation of saturated solution. Now you added one more particle, that is the 10th one, right? If this 10th one has to dissolve, then one particle has to crystallize, right? So that is why if you precipitation of substance A takes place when a small amount of A is added. So at that condition the solution must be saturated. Okay, next, maximum amount of a solid solute that can be dissolved in a specified amount of a given liquid solvent does not depend on. So you know, solubility of solids are independent of the pressure, option number C. Okay, next, low concentration of oxygen in the blood and tissues of people living at higher altitude is due to. So is it due to low temperature, low atmospheric pressure, high atmospheric pressure, both low temperature and high atmospheric pressure? So it is due to low atmospheric pressure. So you know what does Henry's law say? Solubility is proportional to pressure, right? Or I can say, so at higher altitude pressure is less, solubility is less. So inside the human body the solubility of oxygen is less. So that is why we find this is a medical condition, that is your anoxia. Next question, considering the formation, breaking and strength hydrogen bond, predict which of the following mixtures will show a positive deviation from the Raoult's law. If you talk about the positive deviation, right, positive deviation means what? What is the interaction? Weak interactions, right, weak interactions. Now if you see here methanol has strong hydrogen bond, right, but when you put acetone in that, the hydrogen bonding of methanol is disrupted. Okay, and that is what they show positive deviation, option number A. Okay, now colligative properties depend on the nature of the solute particles, the number of solute particles, physical properties of the solute, nature of the solvent, nature of the number of the solute particles, right? That is the definition of colligative properties. Those properties of the solvent which are affected by the amount of solute added are called as colligative properties. Means if you add more solute, the colligative property will increase. If you add less solute, colligative property will decrease. Okay. Next, which of the following aqueous solution should have the highest boiling point? So if you see, delta TB is equal to I into Kb into m. If this I value is more, delta TB value will be more, right? So now you see what is the I value here? 2. I value here 2 Na plus and 1 SO4, so that is 3. I value here is again 2. I value here is again 2. So this is having the maximum I value, right? So that will lead to greater or the higher increase in the boiling point. So correct answer is option number B here. Okay. Next question, the unit of ebullioscopic constant. Now this question is very easy, but if you do not know this term, what is a ebullioscopic constant, then this answer becomes very difficult for you. So you should remember here Kb, okay, is called as ebullioscopic constant, okay, and Kf is called as cryoscopic constant. Okay, so now if you see, we have delta Tb is equal to Kb into m. So what is Kb formula then? Delta Tb by m, right? So I can write this unit will be Kelvin, and if you see molality, so it will be molality inverse. Molality inverse, right? So we have Kelvin, molality inverse. So the correct answer here is option number A. Okay. Next, if two liquids A and B form minimum boiling azeotope at some specific composition, then. So minimum boiling azeotope. Okay, minimum boiling azeotope. What about the interaction, or whether it is positive deviation or negative deviation? Minimum boiling azeotope means it is positive deviation, right? If positive deviation is there, that means A and B interactions, AB interactions are weaker than AA and BB interaction. So you can see here, AB interactions are stronger than those of A and BB? No. Vapor pressure of the solution increases because more number of molecules of liquid A and B can escape from the solution. This is the correct statement. Vapor pressure of the solution decreases because less number of molecules, vapor pressure always increases in case of positive deviation. AB interactions are weaker than those of between AA or BB. Yeah, so this is also a correct statement. So you need to tell, okay, if two liquids A and B form minimum boiling azeotope at some specific composition, then AB interactions are weaker than those of between AA or BB. Okay, we need to talk about the interactions here. Okay, now there is in minimum boiling azeotope we do not talk about the vapor pressure here. Okay, so correct answer is option number D here. Now let us see the next question. 4 liter of 0.02 molar aqueous solution of NaCl was diluted by adding 1 liter of water. The molality of the resultant solution is. So you can see when the mass of the solvent is more, you can relate molality and molarity. Okay, so we can use this formula, dilution formula, M1V1 equal to M2V2. So M1 is 0.02, volume is 4 liter. Now we need to find the new M2 and the volume is 5 liter, right? So now if I want to calculate this one, so I'll get 0.02 into 4, right, by 5. So we'll get this one as 0.8, right? So if you solve this, we'll get 0.016. So correct answer is option number D here. Now next question. We have 3 aqueous solutions of NaCl labeled as A, B and C with concentration 0.1, 0.01 and 0.001. Okay, so we have A concentration 0.1, B concentration 0.01, yeah, 0.01, and C concentration is 0.001. Now the value of Van 't Hoff factor for these solutions will be in the order. Okay, now Van 't Hoff factor is the number of ions produced after the dissociation. So the Na plus and Cl minus will dissociate to give you Na plus and Cl minus, right? Sorry, NaCl will dissociate to give you Na plus and Cl minus. So the Van 't Hoff factor in all the 3 cases is 2. So that is Ia is equal to Ib is equal to Ic, that is option number C. Okay. Next, the Kh value for argon, CO2, HCHO and CH4 are given. So let us note down these values. For argon, CO2, HCHO and then CH4. Now for argon, what is it? 40.39, then CO2 1.67, HCHO 1.83 into 10 to the power of minus 5 and CH4 is 0.413. Now arrange these gases in the order of their increasing solubility. So if you have P is equal to KH into mole fraction, right? Now if you see solubility, we talk about this one. So I can say X is inversely proportional to 1 by KH. So if KH value is less, solubility will be more, right? So KH value is less, if you see this one is the least KH value, so its solubility will be highest. So we can eliminate these 2 options, we can consider these 2 options. Now if you see the next lowest value is of methane, CH4, then it is of CO2, and lastly argon. Correct answer is option number C here. Okay. Next question. The values of Van 't Hoff factors for KCl, NaCl, K2SO4 respectively are. So now if you see, KCl will dissociate to give you 2, so we will have 2, so we can eliminate these two options. NaCl will also give you 2, so these two options are still there. K2SO4, here you might do mistake, so that is why that question is there. It can dissociate to give you 2K plus and 1 SO4 2 minus, right? So total is 3. So correct answer is option number B here. Okay. So that's all we have done with MCQs. Now we'll go towards the the numerical problems, okay, because you will be getting 2 numerical questions from this topic, right? So most of the numerical problems are from your colligative properties, and you need to find the molecular mass in terms of colligative properties, okay. That is I found in every question, it is in that form only. So let us see the first question. 450 centimeter cube of an aqueous solution of protein contains 1 gram of the protein. The osmotic pressure of such a solution at 310 Kelvin is found to be 3.1 into 10 to the power of minus 4 bar. Calculate the molar mass of the protein. Osmotic pressure is given. Let us write the formula for osmotic pressure. C into R into T, right? Now, okay, how to present the answer, I will tell you, okay. See, first step, okay, while doing any numerical problem, please follow this step, okay. First is step number 1. Step 1, write the given values. Write the given values. Step 2, write the formula. Okay. Step 3, show the substitution. Show the substitution. Step 4, final answer with units. Okay, this is very important. This is very important. 4 pillars you need to write. First thing, write down all the given values that you read in the question. Second, whichever is the required formula, note it down. Third, show the substitution. You cannot just write the formula and then write the direct answer. Okay, you need to substitute the values correctly. Then you have to write the final answer with the units. Okay. Now let us solve this question in this format. So this is a previous year question of March 2023. Okay, 450 ml. 1 centimeter cube is 1 ml. So I can write given. What are the given data to me, right? So volume is 450 ml. Okay. Next, 1 gram of protein. So I can write W. Protein mass is 1 gram. Okay. Osmotic pressure is given. Temperature is given to you at 310 Kelvin. Now osmotic pressure you can write with pi. Osmotic pressure is given to you as 3.1 into 10 to the power of minus 4 bar. Now calculate the molar mass of the protein. Okay. So now you can write the first formula. Pi is equal to C into R into T. So see, this is step number 1. Okay. This is step number 2. You need not write step 1, step 2 in the exam. Just to show you, I am writing here. Now we have written. Now what we can do, we can little expand and write the formula, because here we need, okay, one more thing here you need to write. What you have to calculate? You need to calculate molecular mass, right? You can write like this, molecular mass question mark. Okay. Now this formula, there is no molecular masses, so I will write this formula with little expansion of this formula. Okay. You can write in that way also. So it is W2 by M2 into 1000, right, by volume of solution. This is the formula of C into R into T. Okay. Now here what you can do for your easy calculation, you need to calculate molecular mass. You can write the expression in the form of molecular mass. Okay, but that step is optional. Okay, so I'll do like this. I'll write M2 is equal to W2 into 1000 by pi into volume of solution, right? This is done. Then into R into T. Okay, I'll substitute all these things. So now see what we can do now is the step. So this step which I did, that is for my calculation, for my understanding, so that I do not do any mistake while solving the numericals. Okay, so this, but you remember, this is your optional. Okay, you may do, may not do. Okay, so step 2 is done. Now step 3 is what? Substitution of the values. So I'll substitute the values here. So I can write M2 is equal to W2 is 1 gram, right? Write always with units. Okay, that will be very good for you. 1000, R value is 0.083, right? Then you have pi value is 3.1 into 10 to the power of minus 4, right? And then you have also the temperature here, that is 310, right? Okay, let me write it little more clearly. 1 second. Okay, so now this is your step 3, and in step 3 we are going to calculate, we are going to substitute the values. So M2 will be equal to 1 gram into 1000 into, I have R value, that is 0.083. Then you have temperature, that is 310 Kelvin. Okay, then you have pi value, that is 3.1 into 10 to the power of minus 4. Okay, then you have volume of the solution. Volume of the solution is 450 ml. Okay, now once you solve this, okay, just substitute all the values. You have calculator, put the values correctly, check it again and again. Then if you solve this question, answer you will be getting is around 44 gram per mole. Okay, so check this calculation, step 3. So now what is the answer here? Step 4 is the answer with units. Okay, so do not forget to mention the units here. Clear? So let us go to the next question. 1 gram of a non-electrolyte solute dissolved in 50 gram of benzene lowered the freezing point of benzene by 0.40 Kelvin. The freezing point depression constant of benzene is 5.12. The molar mass of the solute is. Again the question is on the molar mass, but now which colligative property is used? Freezing point, depression in freezing point, right? We'll follow the same method. Now I'll not write the steps, like I'll not tell you step 1, step 2. So we'll start with given, right? So let us write down the value again. Mass of the solute, W2 is 1 gram. Then you have 50 gram of benzene, that is W1. 50 gram mass of the solvent. Freezing point of the benzene is lowered, so delta TF is 0.4 Kelvin. Next, freezing point depression constant, that is KF, is 5.12 Kelvin kilogram mole inverse. Molar mass of the solute you need to calculate. Molar mass of the solute. Now if I want, so this is step 1. Next step 2 is depression in freezing point. I'll write delta TF is equal to KF into molality formula. I'll extend and write W2 into M2 into 1000 by W1. Okay, now I'll substitute. You can calculate here, you can make an arrangement as I told you in my last. This is again optional case, but this avoids mistake, right? So it is better if you substitute here, but again that is an optional step, right? Then now we'll do step 3. We'll substitute here. M2 del KF value is how much? 5.12. Okay, next W2 value is again 1 gram, and then you have 1000. Okay, next you have delta TF. Delta TF value is 0.4. then you have W1. W1 is 50 gram, right? So yeah, now if you solve this, you will be getting 256 gram per mole. Okay, correct answer is 256 gram per mole. Okay, so this way if you write the answer, there is no way that even a single mark can be reduced from the 3-marker question. So make sure that you have done correct substitution, unit conversion if it is required you need to do, and then you have to write the answer with proper units. Okay, next question. On dissolving 3.46 gram of a non-volatile solute in 100 gram of water, the boiling point of solution was raised to that of pure water by 0.12 Kelvin. Calculate again the molar mass of the solute. Given values are here. So same thing. Now this is first we have done osmotic pressure, we have done depression in freezing point. Now this question is about elevation in boiling point, right? Now we'll do the same method. We'll first write the given values, right? So what are the given values? We have non-volatile solute, W2 is 3.46 gram. Then you have 100 gram of water, W1 is 100 gram of water. Next you have delta TB 0.12 Kelvin, okay, and then you have molar mass, you need to calculate. Kb value is 0.51 Kelvin kilogram mole inverse, okay, and you need to calculate now. Second step, writing the formula, delta TB is equal to Kb into M. So I'll write expanding way, W2 by M2 into 1000 by mass W1. Okay, one more thing I forgot to say. Here it is better, you need to write the what are these formulas indicating. Okay, these terms in the, so I'll add here also, mention the meaning of the terms. Mention the meaning of terms. Okay, here also it is valid. Here also mention the meaning of the terms. See, generally it is not required, but we should not take any risk and we will write the terms also. So I'll write here all the terms. Delta TB is elevation in boiling point. Kb is what? Kb is your elevation constant, or you can write ebuloscopic constant. Okay, next W2 is mass of solute. Okay, M2 molar mass of solute. Molar mass of solute. Then you have W1, that is mass of solvent. Done, written. Now step 3 is the substitution. So we'll do, that is delta TB is 0.12 Kelvin. Okay, then you have Kb is equal to 0.51. Okay, then you have 1000 by M2 we need to calculate into mass of the solvent is 100 gram. Okay, so now if you solve this, we will be getting M2 is equal to 147.07 gram per mole. Okay, so that will be how you can correctly get the answers. Next question, 31 gram of an unknown molecular material is dissolved in 500 gram of water. The resulting solution freezes at 271.14 Kelvin. Calculate the molar mass of the material. Okay, this is also question is from depression in freezing point. Okay, so first of all let us write down, start with the given values, right? So first is 31 gram of, so what is W2? 31 gram. Okay, next dissolved in 500 gram of water. W1 is 500 gram of water. The resulting solution freezes at this one. So it is given you TF. TF is the freezing point of the solution, 271.14 Kelvin. They calculate the molar mass. Kf value given 1.86 K Kelvin kilogram mole inverse. Then T naught F is your 273 Kelvin. Okay. So now we have this formula, delta TF is equal to Kf into M. Delta TF we can write it in this way. See, you can write it in this way. One second, because we need to expand and write. I'll write delta TF as delta TF is equal to T naught F minus TF is equal to Kf into molality W2 by M2 into 1000 by W1. Okay. So now you can substitute the values here, and please mention the values. Okay, that I am not writing, you need to write in the exam. T naught F value is 273, TF value is 271.4, KF value is 1.86, W2 value is 31, M2 value into 1000 by W1 is 500. Okay, so now if you solve this, okay, we'll put this one. So now if you solve this, M2 value we will get as 62 gram per mole. Okay, so correct answer is 62 gram per mole. Very simple. Similar questions always, most of the colligative properties questions that have been asked is to calculate the molecular mass. Okay, so you can easily do, just remember the 4 colligative formulas, then easily you can do this. Okay, let's move to the next question. Vapor pressure of benzene is 200 mm of Hg when 2 gram of a non-volatile solute dissolved in 78 gram of benzene. Benzene has a vapor pressure of 195 mm of Hg. Calculate the molar mass of the solute. Okay, so vapor pressure. So this question is from relative lowering of vapor pressure. Whenever a solute is added to a solvent, the vapor pressure of the solvent decreases, right? So let us proceed with the given data first, right? Okay, vapor pressure. So pure vapor pressure is denoted as P naught, that is your 200 mm Hg. Okay, next, when 2 gram of a non-volatile solute, so W2 is 2 gram, okay, is dissolved in 78 gram of benzene, so W1 is 78 gram. Now benzene has the vapor pressure of 195, so P is 195 mm Hg. Okay, calculate the molar mass of the solute. Okay, molar mass of the benzene is given to you. So next we need to write the formula. So delta P by P naught is equal to P naught minus P by P naught is equal to XB is equal to NB by NA. So generally in this formula we need NB by NA plus NB, right? But we can ignore this NB in the denominator when the amount of solvent is much more than the amount of the solute, right? So we'll get this formula. So now if you see, we need to do some prior calculations. Instead of NB and NA, I will write the names of the solute and solvent, right? That will be more clear. So here it is solute, I will write solute, and here it is solvent is benzene. Okay, so now if you see what is the number of moles of benzene, C6H6, given mass by molar mass, so that is 78, you have 78 gram of benzene and molar mass of benzene is also 78. Okay, so it will be 1. Okay, number of moles of benzene is 1. Now if I substitute here, P naught value is P naught value is 200, okay, minus P value is 195, right, divided by 200, okay, is equal to, what is number of moles of solute given mass by molar mass. So given mass is 2, molar mass I need to calculate, okay, and divided by 1. So I'll get 5 by 200 is equal to 2 by m, right? So now what will be m here? M will be 2 by 5 into 200, okay. So if you solve this, we'll get 80 gram, okay. So molar mass is 80 gram per mole, okay. So correct answer is 80 gram per mole, right? Very simple and easy question again. Okay, next, 5.8 gram of a non-volatile solute was dissolved in 100 gram of carbon disulfide, okay. Molar mass is given. The vapor pressure of the solution was found to be 190 mm of Hg. Calculate the molar mass of the solute. Vapor pressure of the pure carbon disulfide is 195 mm of Hg, okay. Again same formula question given. First, step number 1, to write down all the data that is given to you, right? So if you see, we have first of all 100 gram of carbon disulfide. So W2 is 100 gram. So remember, 2 is used for solute, okay, and 1 is used for solvent, okay. So W2, sorry, we have here eraser. W2 is 5.8 gram and W1 is 5.8 gram, okay, was dissolved in 100 gram of carbon disulfide, so that is 100 gram, okay. The vapor pressure of the solution was found to be 190 mm of Hg. So P is equal to 190 mm Hg, okay. Calculate the molar mass of the solute. Vapor pressure of the pure carbon disulfide. P naught is 195 mm Hg, okay. Next, so that is done. 76 is the molar mass of the solvent, okay. So I can write M1 is 76. So we have this formula. First we'll calculate number of moles of the carbon disulfide, that is given mass by molar mass. So 100 by 76, okay. So we need this value 100 by 76. I'll keep it like this. Now we'll write the formula. Delta P by P naught is equal to P naught minus P by P naught into XB, and XB is NB by NA, right? So NB value will be 5.8 by something, right? 5.8 by molar mass into here it will be 100 by 76, okay. So now you just substitute the values here. What is P naught value? P naught value is 195 minus 190 divided by 195, okay, is equal to 58 into molar mass into 76 by 100, okay. So now you can solve this molar mass M, okay. So this will give you around 171.91 gram per mole, okay. So molar mass unit, you must remember, it is gram per mole, okay. So every time you solve, you will get gram per mole, okay. Next, another question. 300 centimeter cube of an aqueous solution of a protein contains 2.12 gram of protein. The osmotic pressure of such a solution at 300 Kelvin is found to be 3.89 into 10 to the power of minus 3 bar. Calculate the molar mass of the protein. Again same thing, but this time again it is osmotic pressure question. So given is your volume is 300 ml of an aqueous solution, right? So I can write V equal to 300 ml, okay. Then mass of the protein, that is W2 is 2.12 gram per ml, not gram per mole, because this is not molar mass, okay. Then osmotic pressure, pi value is 3.89 into 10 to the power of minus 3. Next, calculate the molar mass of the protein. Molar mass you need to calculate. So osmotic pressure formula we can write pi is equal to CRT. C I'll write like this, W2 by M2 into 1000 by volume, okay, into R into T. Okay. Now we'll substitute temperature is given, yeah, temperature also given, that is 300 Kelvin. Okay. Now let us substitute what is pi value, 3.89 into 10 to the power of minus 3 divided equal to W2 2.12 M2 into 1000. What is the volume? 300. Okay. Next, R value is 0.083, temperature is 310 Kelvin. Okay. So this is your step 1, step 2, step 3. Next, step 4 is calculation of values. Answer will be 44852.4 gram per moles. Okay. Done. Okay. Next question, give 3 differences between ideal and non-ideal solution. So I told you there will be 2 numerical and 1 theoretical question, right? So there can be this difference between questions can be asked very commonly. So you can remember these points about ideal and non-ideal solutions. Okay, so they obey Raoult's law, do not obey Raoult's law. Delta H mix is equal to 0, not equal to 0. Delta V mix is equal to 0, not equal to 0. AB interactions are equal to A and BB interactions. AB interactions are not equal. Then here you have example and then here you have example. Okay, please note down this table and remember at least, see, 3 marker question, no, in that 3 marker question 1 point must be example. Okay, other 2 you can like take the definition and the second point you can take anything from here. Okay, so this you make as first point, this is third point. Second point, you remember all 3 so that even if you forget one, you have some backup plan to write the correct answer. Okay. Next one, similarly, positive and negative deviation. These are the points you can see. AB interactions are weaker, AB interactions are stronger. Total pressure is higher, total pressure is lower. Delta H mix is greater than 0, less than 0. Here, okay, this point is repeated, so not required. Then example, here also example. So here also you can write the first point, any 3 point, but remember the example has to be there. Okay, example point should be mandatory. Okay. Next one, difference between minimum and maximum boiling azeotrope. So maximum boiling shows negative deviation, this shows positive deviation. Boiling point is more than the individual solvents and boiling point is less than the individual solvents. Then here you have examples. Clear? So you need to learn this table, learn this difference between points. The examples are sometimes very confusing. Even for me, I was feeling difficult with examples. So please note down, remember them, see them every day and mug up the examples. Okay, fine. Next, applications of Henry's law. Okay, so here are the 3 applications. First one you should remember, it is used in the carbonated beverages. Okay, the cold drinks are kept under high pressure to increase the solubility of carbon dioxide. Next, for scuba divers, and then you have to remember at higher altitudes for mountain climbers, the the atmospheric pressure decreases, so the solubility of oxygen in the blood decreases, and as a result of which there is a medical condition which called as anoxia. Okay, so these are the 3 applications of Henry's law that you must remember. Okay, fine. So now we'll go to the second chapter, that is electrochemistry. Now here electrochemistry, if you see, we have total 13 marks from this chapter. Okay, and there will be only 1 MCQ from this chapter and that will be application based MCQ. Okay, and now if you see short answer questions, 3 markers, there is no 2 marker here, right, and no 5 marker here. Short answer questions will get 4. Okay, out of that so here we are getting, right, 4 3s are 12 and here 1 13. Okay, and out of this 4, first one is remembering, 1 is understanding and 2 numericals you will get, 1 application based and 1 hot numerical. Okay, hots, or you can say higher order thinking numerical. Okay, so 2 numerical and 2 questions you will be getting, total 12 marks from this particular chapter and then 1 MCQ. Okay, so I will be first discussing some MCQs here. Okay, which cell will measure the standard electrode potential of copper electrode? Okay, so to standard electrode potential, you should remember that pressure should be 1 bar and concentration should be 1 molar, right? So here if you see pressure is 0.1 bar, we can eliminate. Pressure is 1 bar but concentration is 2 molar, eliminate. Pressure is 1 bar, concentration is 1 molar, can be considered. Next, pressure is 1 bar, concentration is 0.1, cannot be done. So correct answer is option number C here. Okay. Next question, which of the following statement is correct? E of the cell and delta G of the cell are both extensive property. Okay, so if you remember, what is extensive property? Is proportional to mass or amount. Okay, intensive property, independent of mass, it doesn't depend on the mass or amount of substance, not mass, I'll say amount, right? So E of the cell, there is no term of mass there, right? So E naught of the cell is independent, that is, it is an intensive property, whereas delta G is an extensive property. Okay, so you can see here E naught cell is an intensive property and delta G is an extensive property. Option number C here. Okay. Next, the difference between the electrode potentials of two electrodes when no current is drawn through the cell is called as cell electromotive force. Okay, which of the following statement is not correct about the inert electrode in a cell? So inert electrode does not participate in the reaction, correct. Provide surface either for oxidation or for reduction, correct. Provide surface for conduction of electrons, correct. Provide surface for redox reaction. No, it doesn't take part in any reaction. So option number D here. Okay. Next, an electrochemical cell can behave like an electrolytic cell when. So if the external cell potential is greater than the E of the cell, then the cell is reversed and it acts as an electrolytic cell. Option number C here. Next, which of the following statements about the solutions of electrolytes is not correct? Conductivity of solution depends on the size of the ions. Yes, it is correct. Depends on the viscosity. Yes. Does not depend on the solvation. No, it depends on the solvation. So this statement is incorrect. Okay. Using the data given below, find out the strongest reducing agent. So this question is very, very important and I can say a little confusing question as well. Now, reducing agent means what? It will reduce others. It will itself undergo oxidation, right? Now, here what values are given? Here if you see, the reduction potentials are given, right? Now, for any element A, okay, if the reduction potential is low, that means its oxidation potential will be high. Okay, for these values, for these components, if the reduction potential is low, that means its oxidation potential is high. If the oxidation potential is high, means the tendency to get oxidized is high, then it will be a good reducing agent. Okay, so we need to find good reducing agent. For that we need good oxidation potential, and that means it should have least reduction potential. So if you see the fourth one, Cr3 plus 2 Cr, right? This is having the least reduction potential, right? This is having the least reduction potential, right? So that is why the correct answer will be chromium. Okay, Cr. Clear? Okay. Next, next one. Same data is given, the correct reducing order you need to see. Again, that is the what? I can say reducing agent, okay, or reducing power are same. Now, if we want to find the reducing agent, it will reduce others. That means itself it will undergo oxidation. If it is undergoing oxidation and here reduction potentials are there, then we need to find the lowest reduction potential. Whichever is having the lowest reduction potential, it will be good at oxidation and it will behave as a very good oxidizing agent, right? So if you see here again, chromium 3 plus 2 chromium, right? This one is the least value. So here this will be maximum. So we can eliminate these two options. Next, if you see the next lowest value is again here. So we will have Cr3 plus. So we can eliminate this option. Next, if you see, you have 1.36 Cl minus and then you have 1.51 Mn2 plus. Option number B is the correct answer here. Okay. Then next, again, strongest oxidizing agent here. Now, if it is oxidizing agent, it will oxidize others. It will undergo what? Reduction. Now, and for reduction the values are given directly. Whosever reduction potential is highest, it will undergo reduction very easily and it will behave as a strong oxidizing agent. Now, if you see the reduction potentials is highest for this one, right? So, MnO4 minus will behave as a MnO4 minus will undergo reduction and it will behave as a very good strong oxidizing agent. Here do not mark Mn2 plus, okay. Strong oxidizing agent means itself it will undergo reduction, right? So here who is undergoing reduction? MnO4 minus is undergoing reduction, right? +7 to +2. So option number C, okay. Next, find out the most stable ion in its reduced form. So you see what are the reduced forms? Cr3 plus, Cl minus, Mn2 plus and Cr, right? So now if you see Mn2 plus has a D5 configuration, we have already studied in the D and F block chapter. Now because of this Mn2 plus D5 configuration, it is half filled and very stable. So that is why option number D, okay. Next, find out the most stable oxidized species. Oxidized species means you have this one, right? These are the oxidized, these are the reduced species. So you have Cr2O7, you have Cl2, you have MnO4 minus and you have Cr3 plus. So now if you see Cr3 plus, what's the chromium atomic number or electronic configuration? 3d5 and 4s1, and Cr3 plus will have 3d3 configuration, and if you remember it has a T2G configuration which is very stable, okay. So option number A, okay. Fine. Now the quantity of charge required to obtain 1 mole of aluminium from Al2O3, okay. So if you have Al2O3, you need to get, you will be, when it is, you will get 2 aluminium, right? What is the oxidation state here? Aluminium is +3, right? So from, to get 1 mole, so I will write like this, for this we need 6 Faraday, okay, or 6 moles of electrons, but for 1 mole we need 3 Faraday. So correct answer is option number C, okay. I will explain this one again, one second. See, aluminium Al2O3, what is the oxidation state of aluminium here? +3, right? So I can write here 2Al is in +3 oxidation state and it wants to go to this state, right? So how many? 2Al. So we need total 6 electrons for this one. So this is for 2 moles of aluminium. Now for 1 mole of aluminium we will need half of that 3 Faraday. So option number C, okay. I hope this is clear. Let's go to the next question. The cell constant of a conductivity cell, okay. So cell constant, if you see, it is the name itself, it shows that it is a constant value, it remains constant for a cell. Option number D, okay. Now while charging the lead storage battery, charging process, reverse process, right? So at anode what happens? Reduction takes place, at cathode oxidation takes place, right? So that is why you can see at anode reduction happens, so PbSO4 anode is reduced to Pb, okay. Next, lambda naught M NH4OH is equal to, okay. So if we want NH4OH, so we cannot directly take NH4OH at the starting, so this one cannot be there, okay. NH4Cl we can take, okay, then NaOH we can take, and then we can subtract minus NaCl, option number B, okay. Okay, now let us see the question. Lambda naught M for NaCl, HCl and NaAC are given to us. You need to calculate the lambda naught M for HAC. So you can do that easily using Kohlrausch's law, right? So how to present the answer? First you can write lambda naught M of NaCl. So please note down the values. So that is, and then lambda naught of HCl, and then you have lambda naught of NaAC, right? So you have NaAC. NaCl is your 126.4, then this is 425.9 and this is 91, okay. Now if I want to solve this one, lambda naught of NH4OH, okay. So I need first, sorry, lambda naught of HAC, right, sorry, lambda naught of HAC, okay. So you need, first we need H, so I'll get H from here, so I'll take lambda naught of HCl. Then I need AC, I'll get from here, so I'll get lambda naught of NaAC. Now if you see here, what extra we getting? Na and Cl, so we will subtract this one, lambda naught of NaCl. Okay, so HCl value is 425.9 plus NaAC value is 91, and then minus NaCl is 126.4. okay, so if you solve this, we'll be getting around 390.5. okay, so just you need to write this substitution values, units, please do not forget S centimeter square mole inverse. Okay, next question, calculate the standard Gibbs energy for the reaction. Okay, so Gibbs energy, first of all you need to calculate, then write the balanced equation at anode and cathode for the rusting of iron. Okay, so first of all, what is the formula to calculate Gibbs free energy? Delta G is equal to minus NF E naught of the cell. Okay, and what's the formula of E naught of the cell? We have E naught of cathode minus E naught of anode. We'll first calculate E naught of the cell. Now how to identify cathode and anode? So here you see zinc is undergoing oxidation, so this is anode, and this is undergoing reduction, so this is cathode. So silver value 0.8, right? So I can write 0.80 minus anode is one second. Okay, minus 0.76. okay, so we will get what? 0.80 plus 0.76, so we'll get 1.56. okay, now you can substitute this value here. Now if you see, the number N value is 2, here 2 electrons are used, here also 2 electrons are used, so let me substitute this one. Delta G is equal to minus 2 into F is 96500 and E naught value is 1.56. so if you solve this, we'll be getting around minus 301.08 kilojoule. okay, you can check the calculation. Anode and cathode rusting of iron, this you should remember the reactions. At anode, Fe gets oxidized to Fe2 plus. At cathode, there is reduction and we get O2 plus 4H plus gives you 2 water. Okay, so please remember this reaction is important. Okay, next, calculate the EMF of the falling cell at 298 Kelvin. So this is our non-standard conditions, we need to use Nernst equation. So first of all, we can use the Nernst equation. E of the cell is equal to, first write the formula, E naught of the cell minus 0.0591 by N log of, what are the ions present here? Mg2 plus, right, and the reaction is already balanced, so we need not do any balancing also. Ag2, Ag plus, and here you should not forget this 2 to take as a power. Now if you see, what is the value of E naught of the cell? E naught of the cell is given to you as 3.17 minus 0.059. Again, N value you can see here 2 electrons, here also 2 electrons, log of, what is Mg2 plus concentration? 0.13, right, divided by Ag plus concentration is 10 to the power of minus 4 whole square. Okay, now if you solve this, answer will be getting around is 2.96 volt. Okay, you can check the calculation, I have told you the formula. Next question. Okay, fine, this is the same question, I think. Yeah, let us see the next question here. So okay, so delta G you need to calculate. Mg copper given, so here is the smaller, this arrow mark comes here, this is Mg reduction potential, this is copper reduction potential. So first we can calculate E of the cell, right, that is E naught of cathode minus E naught of anode, right, which is cathode, which is anode? Magnesium is undergoing oxidation, so that is anode, so its value I'll put here, that is minus 2.37 and this is 0.34, right. So if I solve this, I'll get 2.71. Now if I want to calculate delta G minus, so first you need to write the formula, right, so that is minus NF E naught of the cell, so minus 2 into 96500 into E naught of the cell is 2.71. So if you solve this, we'll be getting around 523.3 minus 523 0.03 kilojoule. Okay. Okay. Next question is, okay, a solution of nickel nitrate is electrolyzed between platinum electrodes using a current of 5 amperes for 20 minutes. What mass of nickel is deposited at the cathode? Yes, this is very important question from Faraday's law. Okay. So first of all, a solution of nickel nitrate is electrolyzed. So we know this formula, M is equal to Z into I into T. You want to expand this one, Z is equal to molar mass, okay, divided by N into 96500 into current 5 ampere time, sorry, I'm not substituting now, okay. So we'll still put the values into I into T. Mention the meanings here, okay. I is current, T is time, M is molar mass, N is the number of electrons, M is the mass deposited. Now molar mass is given to you as 58.7, okay. Nickel 2 plus N is 2, because you see Ni2 plus, what will be the reduction? Ni2 plus 2 electron is giving you Ni, right. So this reaction also you need to write. Next we have 96500 into current is 20 amperes, and if you want to, sorry, 5 amperes, current is 5 amperes, okay, and time is 20 minutes. So 20 minutes, 1 minute 60 seconds, this one 60 seconds. So if you solve this, we will be getting as 1.825 gram, okay. So how much nickel will be deposited? 1.825 gram will be deposited, okay. Next question, what is molar conductance? How is it related to concentration and conductivity? Okay. So, okay, first of all, what is molar conductance? One point you need to define. Okay, what is molar conductance? Molar conductance is the conductivity of all the ions present in 1 mole of an electrolyte. Clear? Now how is it related to concentration? So you should remember, molar conductivity decreases with the decrease in concentration. Sorry, molar conductivity, molar conductivity increases with decrease in concentration. Okay, then what is the relation? Lambda m is equal to kappa by C. So you can see here, if concentration will decrease, molar conductivity will increase. Okay, so you can write these 3 points, you will get 3 marks. Okay, next question, state Kohlrausch's law of independent migration, give one application. So you can say, what is Kohlrausch's law? First law, you have to write the statement. What it says that the limiting molar conductivity, okay, of the electrolyte is the sum of molar conductivities of cations and anions. Okay, so here I'll recommend, please read NCERT for the exact definition. Read NCERT, okay, for definition. Do not write the any of your own definition. Do not create any definition. So whenever any laws or definitions are asked, try to refer to NCERT and write as it is. Okay, I know this one is a little bigger definition given in the book, but try it, learn it, mug it up, remember 3-4 times and then write down. Okay, so I just explained you. Application. What is the application? It is used for the calculation of lambda naught m of weak electrolytes, because we cannot calculate for weak electrolytes directly, right? So that is why it is used here. What is meant by limiting molar conductivity? So limiting molar conductivity is the conductivity at infinite dilution. Okay, clear? So just frame the sentence properly, and these are the 3 points that you need to write. Okay, next. What is the effect of dilution on molar conductance of weak and strong electrolytes? So first you have to draw, draw a graph to show this. Okay, first you need to write first point. Molar conductivity increases with decrease in concentration for both weak, okay, for both weak and strong electrolytes. Okay, next point you can write down that for weak electrolytes, it increases due to the increase in dissociation, whereas for strong electrolyte it increases due to increase in mobility. Okay, then draw the graph for this. So you can just draw the graph. Okay, so this is like this, you have to show. Okay, so this is the graph of strong electrolyte and this is the graph of weak electrolyte. You can just write down the name of any graph like CH3COH and NaOH. Okay, so here is root over of C and here it is molar conductivity. Clear this one? So this concept I will tell you. Whenever there is dilution, molar conductivity increases. Okay, in case of weak electrolyte it increases much more than in case of strong electrolyte. What is the reason for that? In case of weak electrolyte, on dilution the dissociation increases, so number of ions increases, and as a result of which the molar conductivity increases. But if you see strong electrolytes, here what happens, the number of ions is already dissociated, we cannot increase, but when you dilute it, the mobility of the ions increases, they move much faster, and due to which there is an increase in the conductivity. But the major increase or the rate of increase is much more in case of weak electrolytes. Okay, fine. Next question, state Faraday's first law and second law. So Faraday's first law, what we say, just you have to write the correct statement. I am just telling you the law. The first law says that the mass deposited or the chemical reaction is directly proportional to the amount of charge. Right, this is Faraday's first law. And Faraday's second law says that, and you need to write the statement. Okay, write down the statement and then write down the mathematical formula. Okay, and second law says that when there is series connection, right, M1 by M2 is equal to E1 by E2. Right, so you have to write the complete statement from the book. Okay, you have to learn it. Next, how many Faradays are required to reduce 1 mole of Mg2 plus? So if you see, Mg2 plus will get 2 electrons to get converted to Mg. So how many moles are required? 2 moles, or I can say 2 Faraday. Clear? Okay. Next question, draw a neat and level diagram of H2O to fuel cell and write the reaction at cathode. So here is the diagram. You can see very easy diagram. This is anode side, this is cathode side. On the anode side H2 is pumped, and on the cathode side oxygen is pumped. H2 undergoes oxidation, O2 undergoes reduction. Okay, and cathode reaction is asked. So this is the cathode reaction, that is where oxygen is undergoing reduction by gaining 4 electrons and gets converted to 4 OH minus. Okay, so yes students, these were some of the most important repeated questions of the 2 physical chemistry chapters. Okay, so there are very few theories to study. There is more numericals in physical chemistry. So try to solve these questions, try to practice more questions so that you do not have, like, when you see the question you should be able to solve the question immediately without wasting any time. Okay, so please try, and the theory questions that I have discussed, please prepare their answers properly, definitions, statements, diagrams, examples, please remember them, and we will see you soon with the next class where we will be discussing about the inorganic chemistry. Okay, so stay tuned and subscribe the channel for more such videos.